In this example problem, we are told that there is a copper rod that is suspended in a magnetic field. Now, we want the copper rod to levitate. By levitate, what we mean is we know there is a force of gravity pulling down on the copper rod. So the force of gravity, we use force of gravity is m times g. The mass of the rod times 9.8 gives me a downward force of gravity of 0.581 newtons. So in order to levitate the rod, we want the magnetic force to cancel the force of gravity. So what we want to cancel gravity is we want the magnetic force to be pointing upward, and we want the strength of the magnetic force to cancel the downward pull of gravity, so we want the magnetic force to be that number as well. First, what we're going to do is we're going to ask what direction should the current flow through the rod. Should the current flow to the left or to the right? There's no other possibility because we have a long, thin rod. So to address what direction the current flows, we will just apply the right-hand rule. I'll just try both possibilities. Current flows to the left or current flows to the right. And hopefully one of these possibilities predicts the magnetic force points upward. So if the current is flowing to the right, I align my forearm with the direction of the current. I curl my forefingers into the board. When I raise my thumb is pointing upward, and this is the direction I want the magnetic force to be pointing. So the current is going to be flowing indeed to the right. So the current will flow this way. Here is the current, I. Just for practice and for good technique, we could check to confirm that current flowing to the left will give us the wrong answer for the direction of the force. So if the current is flowing to the left, I align my forearm pointing to the left. I want to now curl my forefingers into the board. Well, this is curling out of the board, but I am allowed to rotate or twist my wrist. Now, when my fingers point into the board, my thumb is pointing down. This is not what we want. So the direction of the current is flowing to the right. To determine the strength of the magnetic force, or the current in the rod, we are going to use the magnetic force equation for a current. So we have the magnetic force on a current is going to be given as ILB sine theta, where in this problem, the force is, we want the force of magnetism to be opposite gravity, so we will have that be 0.518 newtons. The current in the rod is what we're trying to determine. We're given that the rod is 0.175 amp, or the length of the rod is 0.175 meters. And we're given that the strength of the magnetic field is 0.615 Tesla. And the angle here is the angle between the direction of the current and the direction of the magnetic field. So the current flows to the right, the magnetic field is pointing into the board. So the angle between right and into the board is 90 degrees. So then I would have a sine of 90. Now the sine of 90 is just equal to the number 1. So from here, I could go through the arithmetic and solve for the current, and I find the magnitude of the current is 4.82 amps, and the direction of the current is to the right.